everyone. Today we will be discussing the types of chemical reactions as well as how to correctly balance equations. A chemical reaction is a process by which one or more substances change into one or more new substances whose chemical and physical properties differ from those of the original substances. The 5 types of chemical reactions we will be talking about today are synthesis, decomposition, single replacement, double replacement, and combustion. A synthesis or direct combination reaction is one of the most common types of chemical reactions. In a synthesis reaction, 2 or more chemical species combine to form a more complex product. An element reacts with another element to produce a compound. An example of this is the reaction between magnesium and oxygen to form magnesium oxide as seen in the balanced equation. In this experiment, we heated a magnesium ribbon over a Bunsen burner. When the magnesium metal burns, it reacts with the oxygen in the air to form magnesium oxide. The reaction gives off a blinding bright light, which is very dangerous to look at. After the magnesium is held above the flame and the reaction is complete, magnesium oxide is formed. As you can see in the picture, the originally silver metal is now a white powdery product. In this everyday example using food, chicken and bread are the elements, which combine to form a compound, the chicken sandwich. Decomposition is the separation of a chemical compound into elements or simpler compounds. It is sometimes defined as the exact opposite of the synthesis reaction. A compound is broken down into its elements. The decomposition reaction we performed was the burning of sugar, which was broken down into carbon and water. After pouring the sugar into a test tube using a funnel, the sugar was carefully heated over a Bunsen burner. The heat created from the Bunsen burner causes the atoms in the sugar molecule to vibrate faster and eventually break apart. The sugar is chemically changed when these free atoms rearrange themselves to create new substances. What was once a fine white powder was now a brown liquidy substance with a marshmallow smell. Using the chicken sandwich example again, the compound, the chicken sandwich, is broken down into its simpler parts or elements, the chicken and the bread. A single replacement occurs when one element replaces another element in a compound. When this happens, a new compound is formed and an element is released. An element and compound react to form a different element and different compound. The reaction we perform to demonstrate single replacement is between copper and silver nitrate, which yields silver and copper nitrate. In this experiment, we filled a beaker a little over halfway with a silver nitrate solution. We cut a piece of copper to the length of about 1 foot and coiled it so it would be able to fit into the beaker. We placed the coiled copper wire into the solution and let it sit as the reaction began to take place, very slowly. As the reaction proceeded, silver began to form on the copper wire and the solution slowly turned blue. As you can see from the pictures, little spikes of sparkling silver formed. Back to our everyday example. Say I had a peanut butter crackers and Erin had Doritos and a chicken sandwich. We made a deal and traded so I could have the Doritos and she could have the peanut butter crackers. A double replacement reaction is when 2 reactant ionic compounds exchange ions to form 2 new product compounds with the same ions. A precipitate is likely to be formed in this type of reaction. As stated before, it is the combination of an ionic solution and an ionic solution that react and yield an ionic solution and an ionic solid. An example of this type of reaction is when lead nitrate and potassium iodide react to form lead iodide and potassium nitrate. The 2 white crystal-like solids of lead nitrate and potassium iodide are placed in separate test tubes in the test tube rack. Next, each test tube is filled about halfway with water to ensure that each solid fully dissolves. A rubber stopper is placed on each test tube before it is shaken up to prevent it from spilling. After this is complete, the 2 solutions are mixed together by pouring one of them into the other. Immediately upon contact, the solution turns yellow. Potassium nitrate is water-soluble and most of the lead nitrate precipitates out of the solution as a yellow solid. This is a great example of a double replacement reaction. Back at it again with the everyday example here. Say I had water and peanut butter crackers and Erin had Doritos in a sandwich. She wants to trade me Doritos for water. After we trade, I have Doritos and the peanut butter crackers and she has water in the sandwich. The final reaction we will be talking about is combustion. A combustion reaction is a reaction between a hydrocarbon and oxygen to form carbon dioxide and water. Combustion is an exothermic reaction, so it releases heat. So there is the general form of a combustion reaction which was stated before, and in order to demonstrate this, we conducted an experiment where we reacted ethanol, which burns with the oxygen in the air to yield carbon dioxide and water. We filled a graduated cylinder with 1 milliliter of ethanol alcohol and poured it onto a watch glass. Once the alcohol was all on the watch glass, we lit a match and placed it closely on the edge until the solution was lit on fire. The ethanol reacted with oxygen and heat, which created carbon dioxide gas and water gas, which both evaporated as nothing was left on the watch glass. And now we will be talking about the steps to properly balancing chemical reactions. The law behind balancing equation is known as the law of conservation. This law states that in ordinary chemical or physical changes, mass is neither created nor destroyed. And what is the law of conservation based on? This law is based on the fact that the products and the reactants of a reaction are made up of the same number and kind of atoms. There are 4 steps of balancing that you need to know. Identify reactants and products. 2. Count atoms. 3. Insert coefficients. Balance atoms one element at a time. And 4. Verify the results, and remember to never change the subscript. So here we have the unbalanced reaction between nitrogen and fluorine to form nitrogen trifluoride. Based on the subscript on nitrogen and fluorine, it is assumed that there is 2 of each. And based on the subscript on the product, there are 3 fluorines, and 1 nitrogen. Because there is only 1 nitrogen on the right side of the equation and 2 on the left, a coefficient of 2 must be placed in front of NF3. So now there are 2 nitrogens on each side, and that element is properly balanced. The coefficients of 2 must be evenly distributed to the product. There were 3 fluorines before, and now that there is a 2 coefficient, you would multiply that number by 2, which gives you 6. So there are now 6 fluorine on the right side and 2 on the left. In order to make it even, you have to place a coefficient of 3 in front of the F2. When you do this, since there was already 2 based off of the subscript, you multiply that by 3, which gives you 6. There are now 2 nitrogen and 6 fluorine on each side of the equation, and it is balanced correctly. For our final example, we will be looking at the unbalanced reaction between copper sulfate and iron. As you can see, there is 1 copper, 1 sulfate, and 1 iron on the left, and 2 iron, 3 sulfate, and 1 copper on the right. And we will go through the steps to balancing this right now. Because there was originally 2 iron on the right and only 1 iron on the left, a coefficient of 2 is placed in front of the iron on the reactant side. We multiply the amount of iron, which is 1, to get 2. The iron is now balanced. The next step is balancing the sulfate. Originally there was 3 on the right side of the equation and only 1 on the left, so a coefficient of 3 is placed in front of copper sulfate. The coefficient 3 means there are now 3 copper and 3 sulfate. The sulfate is balanced, but the copper is not. There are 3 on the left and only 1 on the right. The final step is simple. You place a coefficient of 3 in front of the copper on the product side. You now have yourself a correctly balanced equation, when there is an equal number of each individual element or the reactant and product sides of the equation. Thank you everyone for watching. I hope you have learned how to identify the types of chemical reactions as well as balance them.
Powered by Video.